Hello everyone, we are group 13 and now we are talking about the third project of constructability review. Let's focus on this map. The location of this project is at the current EW1. It would be a 12-story building with 4 basements. We are at a conceptual phase and we need to demolish the current EW1 building first. The available resources are limited within the roads around the block and no further. Another consideration is the underground pedestrian walkway from the bottom basement to SDE4. The working period is 16 months. Here are some technology challenges and constraints. The first constraint is the limited space. Due to the existing buildings surrounding the site and the narrow roads. The second one is the noise pollution. Because the location is in the university, the noise should be effectively controlled, avoiding affecting the regular function of other buildings. Then the shorter period requires us increasing the productivity. Of course, safety is always a big issue, especially in university where many people work here and there. Finally, there are some existing buildings over the proposed underpass, which may require some special consideration for it.
Hello everyone, this is top-down and bottom-up construction method. Traditionally, buildings with underground basement are built by bottom-up method where substructure and superstructure floors are constructed from the bottom of the substructure or lowest level of basement to the top of the superstructure. So this conventional method, also called the bottom method, is simply in both design and construction. It is not feasible for the large project with limited construction time and site constraints. So the next method is the top-down method. It all have 8 steps. The first step is construct the retaining wall, and the second step is construct piles, place the steel columns or strength where the piles are constructed. The third step is proceed to the first stage of the excavation, and the next step is the cast floor slab of the first basement level. Then begin to construct the superstructure. Besides, proceed the second stage of excavation, cast the floor slab of the second basement level. Then the next step is repeat the same produce till the desired depth is reached. And the next step is construct the foundation slab and the ground beams, complete the basement, and the final step is keep the constraint the superstructure till it gets finished.
Now we talk about the underpass construction. So there are typically 2 methods. The first one is the cut and cover tunnel. This is the traditional method for all the basement construction. It either be top down or bottom up. As there are existing road on the top, so it requires several stages of traffic diversion. In this case, because of the traffic diversion, it requires longer duration time for construction. The typical steps will be like retaining wall installation, soil excavation, disposal, and also strutting, backfilling, decking. If the land is not a concern, then this method will be the most preferred method. The second method is the RTBM, rectangular tunnel boring machine. This is very similar to our existing round TBM, the round shaped TBM for MRT construction. But it's in a rectangular shape because our underpass is in rectangular. It used the principle of the earth pressure balance method, so it's more or less similar to the round shaped TBM. Use the cutter in front to cut the soil and then cast the ring behind. It already in application for our Thompson line in Havelock Station, Stevens Station. It can increase the productivity by 30% and also reduce the manpower by 30%. For example, our Havelock Station, the initial time is 3 to 4 years, now can reduce to 3 to 4 months. Because you can see in our case, the EW1 to SDE4, there are existing building on top. In this case, the traditional method is no longer valid. So in this case, we have to use the RTBM method in our proposal.
On the structural work, 3 methods were considered. First, the cast in situ method. And then we have the free precast method where elements such as the slab are casted off-site and then transported for installation. And we have the PVC where modules are fabricated off-site in a controlled environment, which comes with finishes for the walls, the ceilings and floors all done up before they are being transported to site for installation. Our group have evaluated each method in terms of safety, environment quality, time, productivity, cost and accessibility. First, cast in situ is good for its savings in terms of construction cost. But this may not be substantial because we also need to put in more manpower and skilled labor for the reinforcement and formwork at site, which typically takes longer over the other two methods. We have precast, which is good for its quality and shorter time for construction, as there's no waiting time for concrete quarrying at site. Then the PVC is also good for its better site safety, better quality and shorter time for construction. This site safety is further enhanced with minimum activities at site. Quality control is easier at the manufacturing facility, and there's very minimum weightage. PVC is also the fastest method with the highest productivity. Hence, our group has decided on PVC after considering the pros and the cons. We know that PVC is very costly, but this should not be the main concern as we can tap on the government funding and also uses the services of the integrated construction prefabrication hubs. Accessibility is another issue that needs to be addressed. But based on the preliminary study, we found that these may not pose any problems if we implement PVC. Furthermore, we have checked with the client and relevant authorities that access, larger working space and holding area at this location can be arranged. Next, I'll hand over to Shishuan for the conclusion.
Based on what we talked about, the following three methods are chosen. First is top-down method, which addresses the constraints of shorter time and limited space. Second is RTBM, which also addresses the shorter time constraint and effectively avoid the interference of existing buildings. The third method is PPVC, which addresses the constraints of safety, shorter time, and pollution. So in conclusion, we believe we have effectively addressed the main technology constraints and the challenges.